Good afternoon to all of you. Uh, in the previous lecture, we have learned about the Vogel's approximation method, and we have also studied the least cost method, that was matrix minima method, northwest corner method. So there were three methods which were used in the transportation. Okay, so all the three methods we have already learned, and I told you that after completing these three methods, we will solve uh, the unbalanced problem of transportation. So in the today's lecture, we will go through the unbalanced transportation problem. Means what is the process and what types of problems are called your unbalanced transportation problem. And also we will see the condition of degeneracy. We will see the condition of degeneracy. Okay, so let's start the today's class with unbalanced transportation problem. So here I'm sharing my screen. So you are looking the title, that is unbalanced transportation problem and condition of degeneracy. Okay, so let's start. Actually, what is transportation problem? I told you in the previous lecture that transportation is a special kind of linear programming. Transportation is a special kind of linear programming in which goods are transported from a set of sources to a set of destination. I have also from where you send the product, that is called your source, and where you send the product means from and to. From is called your source and up to is called your destination. Okay, so when we transport it from a set of sources to a set of destination subject to the supply and demand of the sources and destination respectively. Okay, so according to the condition, the requirement which is demanded by either market or dealer is called your demand, and the product that you send to the market or to the dealer is called your supply. Okay, such that in the whole process we have to minimize our cost. In this process we have to minimize our transportation cost. Okay, so by using these transportation method, we will minimize our transportation cost. Sometimes it is also called a Hitchcock problem. Okay, now how many types of transportation problem? There are mainly two types of transportation problem. The first one is balanced transportation problem and the second one is unbalanced transportation problem. We have solved many examples of the balanced problem in the NWCM method, in the LCM method, that was matrix minima method, and also in the Vogel's approximation method. In all these methods we have solved the balanced transportation problem. Okay, and what is the unbalanced transportation problem? In the previous solutions we have seen that the supply and demand were equal. The supply and demand were equal. So when the supply and demand were equal, so these type of transportation problem called balanced transportation problem. And when the supply and demand are not equal, means supply and demand are not equal, then it is said to be an unbalanced transportation problem. It means either supply can be more or your demand can be more, and vice versa also. Okay, so how we will manage this type of problem? So in this type of problem we have to add a dummy row or dummy column. In this type of problem, means in unbalanced transportation problem we have to add a dummy row or dummy column according to the condition. So let us see what are the condition in which we have to add the dummy row and dummy column. Okay, after making the unbalanced problem to balanced problem, we will solve that. Okay, and after making the unbalanced into the balanced problem, the process of solving these balanced problem similar as the previous that I have told to you. Okay, so let us see condition of unbalanced problem. So for we have discussed the balanced TP where the total requirement equal to total capacity. Let us see here summation of AI. Summation of AI is equal to summation of Bj. Okay? Summation of AI is equal to summation of Bj. I am increasing the size that you are looking in your screen. Okay, this. Yeah. Okay. Now look on your screen. Here, summation of AI. I write down the I in the suffix and also J in the suffix. Okay. This. When the condition is like this, is called your balanced problem. Okay. So let us down here, write down here, balanced problem. Balanced problem. Okay. When the condition is like this, summation of AI is not equal to summation of Bj. Means like this. This is okay. When the summation of AI is not equal to summation of Bj, then these type of problems called unbalanced problem. Unbalanced transportation problem. In the next slide, I will write transportation insert in TP. Okay. Yes. I have written down this. Okay. Now, what are the summation of AI and Bj are here? Okay. What are the AI and Bj here? So your AI, summation of AI is, this is your total capacity. Total capacity. Or you can say that also this is your supply. Okay. So summation of AI is either your total capacity or supply. Means the capacity of the factory or plant that is manufacturing. Okay. And what is the summation of Bj? Summation of Bj. Your summation of Bj is total requirement. Okay. So this is total requirement total requirement. Or you can also say that this is your demand. Okay. So here summation of AI and summation of Bj are representing capacity and demand. Now, for these conditions, where I is representing the number 1 to m, means there are m number of sources. Okay, here m number of sources. This here I represents I equal to 1, 2, 3 up to dot m. So these are your m number of sources. Okay. And what about the j? J is also your up 1 to up to n. So this there represents your total number of destination. This is representing number of destination. Okay. So now you have what is your balanced problem and what is your unbalanced problem. Okay. But according to the condition, this is also occur in two types. Thus, if in a transportation problem, the sum of all available quantities is not equal to the sum of requirement, then such problem is called an unbalanced transportation problem. Just I have shown you in the this screen. Okay. I have written down the condition of balanced problem, balanced transportation problem, and unbalanced transportation problem. This. Okay. Now you have already know the balanced problem solution, but now how we will solve the unbalanced problem. In the previous lectures, you have seen that how can we solve the balanced transportation problem. So we have solved three types of, we have solved the balanced transportation problem by three methods. These NWCM method, matrix minima method, that is also called least cost method, and the third one is Vogel's approximation method, and or either it is, this is also called BAM method. Okay. So you have the solution procedure of condition first, but how you will solve the second type of condition means when if your problem is like this, means summation of ai is not equal to summation of bj. So what will you say? Let us see. An unbalanced transportation problem may occur in two different forms. And what are these two different forms? Either excess of availability or shortage of availability. Either excess of availability or shortage of availability. Similarly, you can also say that excess of requirement or shortage of requirement. Both are the statement of same. Both the statements are same as. You can say excess of availability or excess of means shortage of requirement, and shortage of availability means excess of requirement. Okay. Either you can also say that or shortage of requirement. Okay. And in the next, you can also say that or excess of requirement. You can explain this statement like this. Means sometimes you have excess supply, or you can say that you have shortage of demand, and sometimes you can say that you have shortage of supply and excess of demand. Actually, in the real or in the practical, this is not possible. The condition first, that is this summation of ai equal to bj. In the real world, this situation occur rarely, or you can say that this is very difficult in practical, that your supply is equal to demand. Okay. So that when the supply is not equal to demand, then you have to follow the second method, that is unbalanced problem. Okay. So for these two forms of unbalanced transportation problem, what you have to do, how you will solve that. Okay. So when the excess of availability, There is case 1 when excess of availability, mean you can say that summation of AI is greater than summation of Bj, means supply is more than the demand. Supply is more than the demand. And how it is possible? How it is possible? So let us take an example. Suppose you are manufacturing any product. Okay, you are manufacturing your product according to the demand of market, and after some times you have increased your production rate. After some times you have increased your production rate. So what will be happen? So what will be happen? The production will be increased. The production will be increased, but the demand in the market is still remaining same. The demand of the product is still remaining same. So what will be happen? Means the supply will be excess. Supply will be excess and demand is still remaining previous. Clear? So this is the case of excess of availability, or you can say that excess of supply. So what is the rule for to solve this type of unbalanced problem? Then whenever summation of AI is greater than summation of Bj, means if your supply is greater than the your demand, so we will introduce a dummy destination column. Remember, we introduce a dummy destination column in the transportation table. In the transportation table. Now, the unit transportation cost to this dummy destination are all set equal to 0. Read this statement carefully. Okay, the requirement at this dummy destination assumed to be equal to the difference of summation of AI minus summation of Bj. Summation. We will also look an example in the next slide, but first we will understand these two cases. Okay. So, and what about the second case? When the availability is shortage. When the availability is shortage means just opposite case. If summation of AI is less than summation of Bj, means your supply is less than the demand. You are producing less unit according to your demand. So what will be the working rule for this case? So whenever summation of AI is less than equal to summation of Bj, means supply is less than demand, we will introduce a dummy source row. We will introduce a dummy source row in the transportation call table. Okay, and the unit transportation cost to this dummy source are all set equal to 0. And the requirement at this dummy destination assumed to be equal to the difference of summation of Bi minus summation of Aj. Sorry, summation of Bj minus summation of Ai. Okay. So let us take an example and we will apply this condition, any one of this condition in the given problem. So let us see, here we have a problem. The problem is a company has 3 factories. Okay, a company has 3 factories at A, B and C. Suppose that these are cities, A, B, C are cities, which supply warehouses at D, E, F and G. Means these 3 factories supplies his product, own product, to the warehouses D, E, F and G. Okay, the monthly factory capacities are 160 unit, 150 unit and 190 units. This is the production capacity of the factories respectively, and monthly warehouse requirements are 80, 90, 100 and 160, okay, respectively. Unit shipping costs in rupees are as follows. So in the table given that these are the per unit shipping cost, means if you want to send the product from factory A to warehouse D, the per unit shipping cost is rupees 42. And if you are sending your product from factory A to warehouse E, then the shipping cost is rupees 48 per unit. Okay. And if you are sending your product from factory A to warehouse F, then your per unit transportation cost is 38. And if you are sending your product from factory A to G, then per unit shipping cost is your rupees 37, and so on. From B to D, B to E, B to F, B to G. These are the per unit transportation cost. And similarly, from C to D, C to E, C to F, C to G, per unit transportation cost are these. Okay. Now, we have to find the optimum distribution for this company to minimize shipping costs. So today, we will see only the how we will solve this unbalanced transportation problem. How we will know that this problem is either unbalanced or not. So let's write down this table in the Excel. Okay, I'm writing down here A, B, and C. These are factories. B, E, F, and G. These are the warehouses. Let's increase the size. Okay. This. I have increased the size now. Now I will write down the per unit cost in different cell is from factory A to different warehouses. So I am writing down the per unit transportation cost. So for the factory A to D, E, F, G, 42, 48, 38, 37. These are the per unit cost. Okay, from A to D, A to E, A to F, A to G. These are the per unit shipping cost. Okay. Now similarly for the B. Now these are the per unit shipping cost from factory B to D, E, F, and G. Okay. Similarly from factory C. Yes. Now we have written down all the per unit shipping cost from different factories to different warehouses. And what are the requirements and capacity? So write down the capacity of different factories. This is the capacity. Okay. So capacity for factory A, how much? Here. A company has factories at A, B, and C, which supplies warehouses at these places. The monthly factory capacities are 160, 150, and 190 units respectively. Means the capacity for factory A is 160, for factory B is 150, and for factory C is 190. So we will write down all these capacity in front of factories. Okay. are the capacity of the factories. Now, what are the requirements? Or you can say that demand. So write down here either demand or requirements. Okay. I have written down requirement here. So what is the requirement of warehouse D? 80, 90, 110 and 160. Okay. So these are the demand for different warehouses. So I will write down these demands: 80, 90, 110, 160. 80, 90, 110 and 160. Okay. So now I have written the demand. Let us make it bold. These are the demand and this is the capacity. Okay. Now let us check either this problem is balanced or not. So what we have to do, we will find the sum of AI. Sum of AI. AI. Summation of. Okay. Let's check summation of AI. We will write down AI here. AI. Okay. Now we have to find the sum of AI. So 150 plus 160 plus 190. Okay. Now get the sum of all these. So get auto sum. So the total capacity of all the factories is 500 units. That is 150 plus 160 plus 190. The total capacity will come 500 units. Again, let's check the requirement of different warehouses, means BJ. So let's check BJ. 80, 90, 110 and 160. Okay. So let's do auto sum for all these requirements. How much? 440. Okay. Requirement is 440 units and the capacity is 500 units. So here we are looking that the capacity is not equal to your requirement. Okay. So what we have to do? When our supply is less than our demand, then go through the condition, that is case 1. Case 1, working rule. When your supply is excess than your requirement, so we will introduce a dummy destination column. We will introduce a dummy destination column in the transportation table. So we will introduce a dummy column. So this is our table. So I am writing down this table again. Just below it. Okay. This. And we will introduce a dummy column. So I am introducing a dummy column. Dummy. And I'm writing down R. R means requirement. Okay, dummy requirement. Now, how much? How we have to write this? Now, look at here. The unit transportation cost to this dummy destination are all set equal to 0. Okay, so it means all the per unit shipping cost, all per unit shipping cost, that is 0, 0, 0. Okay, these are your per unit shipping cost. Okay, and how much was less? So we have to add how much? Look at here. The requirement at this dummy destination assumed to be equal to the difference of summation of AI minus summation of BJ. This Control C. We have to add this unit. Okay, we have to add this unit. So how can we find this? Get, we have summation of AI. Summation of AI is 500 and summation of BJ is 400. Okay, summation of AI is 500 and summation of BJ is 440. So, and we have to find the summation of AI minus BJ. So let's apply the formula, that is summation of AI is your 500 minus summation of BJ, that is 440. So how much will become? 60. Okay, so 60 is the requirement. 60 is the requirement. So we will add 60 here. We will add 60 here. After adding this, again we will write down our previous column, that was capacity. So Control C, and I have written down here. So this is your capacity. Now we have now balanced problem. Okay, now let us check sum of 150, 160, 190, 500. Okay, again I am deleting this 500 and again adding 80, 90, 110, 160 plus 60 and a auto sum, that is 500. Okay, so now in this case, your summation of AI and BJ are equal. Okay, so this is the condition of this. Previously the condition was this. Previously the condition was this. This, okay, previous condition was this, before, after. Okay, so this is your unbalanced. So unbalanced, and this is your balanced. This is your balanced problem. So now you have the unbalanced problem, you have converted it into balanced problem. Now this problem can be solved by any of the three methods. Okay, now you can solve this balanced problem by any one of the previous three methods, that was NWCM method, either LCM method or WAM method. Okay, so I am only giving you the solution if you want to try it in your home. So this is your solution for this example. Okay? This is the solution of this example. Means 160 to AF. 160 allocation will be for AF. Okay. Means here. Write down here F. AF. Okay. 80 to BD. BD means this. This column will have 80. And 10 to BE. 10 here. 60 to BG means here. 80 to CE. CE means this. You can check by which method these are the allocations. By which method these are the allocations. So you have to apply all these three methods. Okay. That is NWCM, LCM and WAM. So this is the your solution of unbalanced transportation problem. Now we can solve this problem using WAM to determine the basic feasible solution and then use the Modi method to find the optimal solution. Now again we have to check something else. And we have solved this problem in example we have already solved the transportation problem by WAM method. So we have already solved. Now you may like to try the remaining solution yourself. Okay, the optimum allocation will be like this. Now note that how many are these allocations? How many are these allocations? 1, 2, 3, 4, 5 and 6. Okay, there are 6 allocations. These are 6 allocations. And let us see condition. To get the optimal decision, after finding the initial feasible solution, you have to check either this solution is optimal or not. You have to check the optimality. Okay, now note that if the number of allocation in the basic feasible solution is less than m plus n minus 1, note that this point, that is m plus n minus 1, we first go through the special case of degeneracy. We go through the special case of degeneracy and then apply the test of optimality. Let us explain how the problem of degeneracy is dealt with in the transportation problem. Okay, so let us check how the degeneracy problem occurs. So first I am telling you here m is your number of rows. Okay, and n is your number of column. Okay. Now m plus n minus 1, what is this? M plus n minus 1. To check the degeneracy condition, we have to apply this formula. Means if your allocations are m plus n minus 1, you have allocated m plus n minus 1, then your solution is optimal. Okay, if your solution is not according to this formula, then your solution is not optimal, and then you have to check the optimality test. Okay, let us see. Degeneracy can occur at 2 stages. Degeneracy, now Let us see what is degeneracy. It may happen sometimes that the number of occupied cells means allocated cells, is less than m plus n minus 1. In the previous examples that we have already solved in all the trees method, we have always checked that the allocation was always m plus n minus 1. But sometimes it could be possible that the allocation is not equal to m plus n minus 1. Means sometimes it could be happen that the number of allocated cell is less than m plus n minus 1. Then such situation is called your degeneration. When your solution called degenerate solution. When your allocations are not equal to m plus n minus 1. Let us write down here. M plus allocation or occupied. Allocations are less than m plus n minus 1. Less than symbol. If this is less than m plus n minus 1, then the problem of degeneracy. So this occur if this condition, this situation arises. This situation arises when your solution or allocation is follows this condition. Okay. If your allocations are equal to m plus n, then non-degenerate. This is the condition for non-degeneracy, and this is the condition for degeneracy. Degeneracy and these are the conditions for degeneracy and non-degeneracy. Now, sometimes happen your occupied cells are less than m plus n minus 1. Then this type of situation is called your degeneracy problem. Then how we will handle it? We handle such a situation by introducing an infinitesimally small allocation E. Suppose that E in the least cost and independent cell. Let us explain it in the next in the Excel table. Okay. This means that if E is added to or subtracted from any quantity, the quantity remains unaltered. That is, the value of E is nothing but 0. But we do not write 0 in the place of E, as it is one of the allocations. Remember this. And will not come into counting if it is written as 0. So we write E and not 0 in its place and count it as one of the allocation. Let us, I'm writing down here. Suppose that this is your, I am deleting this. Okay. So now, suppose that you have non-degenerate solution. For this example, count here how many rows and column for this. Column 1, 2, 3, 4, 5. Okay. And the number of rows 1, 2, 3. 5 plus 3. 5 plus 3, that is 8. Okay. 8 minus 1 equal to 7. So how many allocations should be there? That is 7. And let us count how many allocations are there. 1, 2, 3, 4, 5, and 6. There are 6 allocations. Okay. So this problem is degeneracy. This problem has of degeneracy. Okay. So we had to introduce a very small quantity. Either you can say epsilon or E or delta. A symbol will be used here. Okay. These are the symbols. Here, these are the symbols that we will use to allocate. Actually, this quantity is very small. We will not write 0. Actually, this quantity tends to 0, but this is not 0. Okay, this quantity is not 0. This is tends to 0. This is tends to 0. So I'm writing down here. This is your, either you can say that E or epsilon or delta. You can introduce any number, any symbol according to your convenience. Okay, so most of the books have either E or epsilon. Okay, or in some books have delta also, just like triangle. Okay, so this is, suppose that very small equal to very small. Okay, very small. Now, since this is very small, so in the calculation we will take it as a 0. We will take it as a 0, but we will not write it as a 0. We will not write it as a 0. In the calculation we will take it as a 0. Okay, so degeneracy can occur at 2 stages. Listen here. Now, the thing that I was telling you, this means that if E is added to or subtracted from any quantity, the quantity remains unaltered. Means if we add, suppose that you are adding 60 and plus 60 plus E, so it will become 60. It will become 60. Okay, this is also that you can also see that 60 plus 0 equal to 60. Actually, this is, but we will not write here 0. We will not write here 0. Here we will assume this as a allocation. Here we will assume as a 1 allocation. Okay. Now, so we write E and not 0 in its place and count it as 1 of the allocation. Means when we will assign epsilon or E, then it will be known as a allocation. Okay. So next, what are the conditions for degeneracy? Degeneracy can occur at 2 stages. The degeneracy can occur at 2 stages. The first one at the initial solution. At the initial solution means when you find the initial feasible solution. So you will check that there are the allocations are m plus n minus 1 condition is existing or not. Okay. So if there is condition is not existing, then you can say that your transportation problem is degenerate problem. Okay. And the second one is during the testing of optimality test. When you will check the optimality, then this problem can be arises. This problem can be arises that your transportation problem could be degenerate. Okay. So in these 2 stages, you have to check the degeneracy case. Now, to resolve degeneracy case, we make use of an artificial quantity, that is either E or epsilon or delta or this. The quantity means this symbol is assigned to that unoccupied cell. Remember here, that unoccupied cell which has the minimum transportation cost, means which has the minimum transportation cost. So let us see. Yeah, one thing more. We will not consider the transportation cost zero. Okay, so we will assign this epsilon or small quantity in these per unit shipping cost. So let us see which one is minimum transportation cost. That is 37. Remember one thing more. If this cell is not occupied, then we will assign a small quantity on particular cell. If this is already allocated, then we will see another smallest shipping cost, per unit shipping cost. Okay. So suppose that there is no allocation, means in 37 there is no allocation, then we will assign a epsilon. Let us I am assigning epsilon. Oh, this has become bigger. So this symbol, this I have allocated this. This is not some. Yeah, I have allocated epsilon on this unoccupied cell. Remember one thing, you will allocate it only non-occupied cell which have minimum cost. Okay, never allocate epsilon on the already allocated cell. So this is the condition. So after allocating this, you will again solve the problem. So this is the condition of degeneracy. So today you have learned the condition of degeneracy and unbalanced transportation problem. So in the next lecture, we will solve the problem of transportation using by body method. Okay, that is also called optimality test. In the next lecture, we will solve the optimality by modification method. So if someone has any query, you can ask now. And one thing more, everybody write down your name in the chat section. Everybody write down your name in the chat section. I am checking. Abhay Raj Madesia, Alka, Anamika, Anjali, Ayushi, Maurya, Isa, Sneha, Uttar. Let us check here. Arshid, Abhay, Arya, Anamika, Ayushi. Swati Dubey. Swati Dubey, you have not write your name, I think, in the chat section. That's okay. I think everybody is written. So